Welcome to Pomodoro Joe for Friday, August 4th, 2023. Today we're doing LeetCode problem 139, word break. This is a medium problem. All right, so we're given a string, S, and a dictionary of strings, word dict. Return true if S can be segmented into a space-separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the same segmentation. All right, so they have an example here. LeetCode, and the word dict is leet and code. So the result is true. We can make LeetCode from leet and code. All right, the next one, apple, pen, apple. We have apple and pen. That is also true because we can use apple and pen and apple again. And then finally, we have cats and dog. We have cats, we have dog, we have sand, we have and we have cat. But we have cats and with this D being shared between and dog. So that does not work. So we return false. All right, so we'll put 25 minutes on the Pomodoro timer and we will get started. So with this one might seem a little overwhelming. We have one string. We have to figure out where do we put the spaces in that string to create just these words in the dictionary. Well, one thing I like to do when I get into a situation where I'm not really sure where to start, I try to think about the ending. Where do I end? So how do I know I'm done with this problem? Now there are two cases that come to mind. One is if this string that we get as our input is empty, then we know we're done. We can return true. We can make that empty string out of just word dictionaries or words in the dictionary. The other end case that comes to mind is what if this string itself is just in our dictionary? If the entire string is in the dictionary, again, we can return true. So we have two end cases. What about the non-end case? Well, that gets a little bit harder, but I know I can break my input string into two strings, and I can look for those strings in the dictionary. Or even better, I can break it into two strings, just look for one of the strings in the dictionary. If that string is not in the dictionary, it doesn't matter if the other string is. Or if it is in the dictionary, then the other string, we don't actually need the entire string to be in the dictionary. We just need to know that we can break that string into smaller strings that are in the dictionary. So this leads me to a recursive function. Essentially, I can go through, find some place to split my input string. We can split at the L, we can split at the E. We can find some place to split this input string. We'll split that string, we'll take what's on the left side, check to see if it's in the dictionary. If it's not in the dictionary, then it doesn't matter what's on the right side. This is not going to return true. If it is in the dictionary, let me back up. When we split the string, if the left side is not in the dictionary, we don't just return false. We can move our split to the next character. So we can keep moving our split down the line until we run out of characters. So we can't just return false as soon as we determine, oh, this split isn't in the dictionary. All right, if we do find some split that's in the dictionary, so we split at L, it doesn't work, E doesn't work, oh, but when we get to T, leet is in the dictionary. Next, we have to check for the remainder of the string in the dictionary. So we just look at code. Instead of looking to see if code is in the dictionary directly, we can recurse and look to see if code, the entire, I guess, right side of our remaining string is in the dictionary. That's more apparent in this example here. When we get to apple, so A, P, P, not in the dictionary, but when we get to apple, this is in the dictionary. So now that we know that this is in the dictionary, we'll just recurse on the remainder of the string. So we have pen, apple. So we don't just check to see if pen, apple's in the dictionary, we will recurse to see if pen, apple satisfies these requirements. All right, so let's get started. Let's just write some code here. So we'll have some recursive function, word break recurse. All right, and this will take the remaining string, what's left of our string. All right, and we don't need to pass in the word dictionary. We'll just use the word dictionary as sort of a global out here. All right, so what are these base cases that we talked about at the beginning? How do we know that we're done? Well, first, if we have an empty string. So if the remaining string is an empty string, then yeah, it doesn't matter what's in the dictionary. We know we can create this string, so we can just return true. Okay, what is the other base case? Now, if this remaining string itself, the entire string, is in our dictionary, we can also return true. So we can just say if remaining s is in our word dict, then we can return true. All right. Now what else? I guess we can get to another base case. We didn't really discuss this one. What if we can't split our string? In what cases can't we split our string? Well, one is this empty string case. Well, we already have a base case for that. What about if the string is 1 character long? So if we get to this point, we check to see if this 1 character is not in the dictionary. If we get to that point, we can't split the string anymore, and we'll have to return false. So this is another base case. So if the length of our remaining characters, or remaining string, if that's equal to 1, it's not in the dictionary because we already passed this check. At this point, I can't split that string any further, so I have to return false. Finally, we get to our recursive cases. So for this one, I need to choose every single split point. Basically, I'll split after the first character, then I'll split after the second character, split after the third character, keep splitting this string into a left and a right string. So let's just do this. We'll have some split point. So for whatever split point we have, in the range, we'll go from character 1. We're not going to start at 0. We'll start at character 1. So that's basically going from L, we'll split after character 1. So that gets L on the left-hand side and E, and LeetCode on the right-hand side. All right, so we'll go from range of 1 to the length of our string, or our remaining string, I should say. Okay, so we're going to split our string basically at every possible place along the way. We'll split after the first character, after the second, after the third, after the fourth, all the way up to the end of our string. Now I might actually be able to say remaining string minus 1. We can check on that. I'm not 100% sure. Okay, so now we're going to split this into left and right. So let's do our left string. So our left string is just our remaining string up to our split point. So we can just use this bracket up to our split point. So bracket, colon, split, close bracket. So that's our left-hand side. Now what's left on our right-hand side? So the right-hand side is the remaining string. And that's going to be everything from the split point to the end. So we're splitting right at the split point. Everything to the left is going to be in left. Everything to the right is in the right. Now we check, is the left-hand side, is that string in our dictionary? All right, if left is not in our word dict, well, in that case, it doesn't matter if we can split the right-hand string. This left-hand string is not in the dictionary, so we can't use this. So we'll just continue. We're not going to return false. We'll continue. We'll just move on to the next split point. All right, if the left-hand side is in our word dictionary, at this point, we want to recurse on the right-hand side. So we'll actually check the right-hand side to see if we can split that into all words that are in our word dictionary. So in this case, we're going to have to check our return value. If it's true, then we can just return true. But if it's false, it doesn't mean that we're done. We might have other split points that will get us the right answer, or will get us a true answer. So we'll just have to check to see if it's true. If it is true, then we'll return true. If it's not true, we'll keep going. So first, let's just check. If, and I'm going to grab this here. If we do this recursive call and we just pass in the right side, if that is true, then we will return true. If it's not true, we don't return false, we just keep going. Now, if we make it all the way to the end and we haven't returned true, well, now at this point, we know we don't have a true answer. We'll have to return false. All right. And then out here, we need to make our initial call to this whole thing to start it all off. So we'll just return the recursive function, and we'll pass in the entire string. All right, so this should do it. Let's run this and see how we do. And it works. Let's see if we can pass all the tests. Time limit exceeded. This is too slow, but I think we're on the right track. We beat 35 out of the 45 test cases. So let's grab this test case and we will use that. All right, for this, I will actually show you the dynamic programming solution, but you can use caching. So we'll use dynamic programming. And for this, we'll just use a dictionary. All right, so in this dynamic programming, this is essentially memoization. Maybe I'll call it memo. I'll call it DP, it's fine. So in this case, we're just going to check whether or not our remaining string is a key in the DP dictionary. So let's actually do this. Let's call key and its remaining s. So we're actually going to use our input as the key. Now if the key is in our dictionary, that means we've already seen this input before. We've already cached the output. We'll just return our cached output. So we'll return DP for this key. So that's the first thing that we do. Next, we'll just go through, find all of our returns. Any place we have a return, we're going to store that in our DP for this key. So let's grab this. So here, set this to true. And then here, we'll set DP. Whoops, I missed the D. This one's also true. This one's false. Let's see, this will be true. And down here will be false. All right, so this does the same thing that the cache decorator will do. We're just doing it ourselves. All right, let's see if this works. All right, it works, and we're passing that one test case that was giving us the timeout. Let's try this whole thing. And we pass. And we do pretty well. We beat 70-something%. We beat 76% for runtime and 10% for memory. So yeah, we do pretty well. All right, let's jump back and see if we can speed this up. One thing we could do, we could try caching instead of our own DP. Let's try that actually. See if caching over our own DP gives us an advantage. All right, so for this, I'm using the cache decorator. This is in the Func Tools library. So this will do the same thing that our DP was doing. Let's see if this helps. All right, so that works, and it actually does worse than our own DP. That's interesting. So maybe we'll go back and use our own DP. All right, let's do that. Put our own DP back in. And then one thing we could do, so this key is just our remaining s. We don't actually need to have this separate key, so maybe we'll do this. All right, that's gonna save us a little bit. What else can we do here? Well, one thing we could try, instead of doing this if continue, we could have this if and embed this if and remove this not. So instead of saying if this left is not in the dictionary, continue, we can say if this left is in the dictionary, then we'll check to see if the remainder is true. Let's just try our DP here first and see if that gets us anything. Right, this should be a remaining s. There we go. All right, let's see. That doesn't. Actually, having our separate key worked better. That's interesting. All right, we'll go back to having that separate key. Okay, one more thing. We'll go try this. So instead of saying if the left is not in the word dictionary, let's say if the left is in the word dictionary, then we'll check to see if the right is also in the word dictionary, or the right is recursible. I don't know what the word is. All right, let's try this. All right, and now we're down to a 45%. We're just doing worse and worse. Okay, I'm gonna do this one last time. Gonna get rid of our DP. We're gonna go back to using the cache. I know it didn't work as well for us, but I think if we reduce the number of lines of code that the interpreter has to parse, it might give us a better answer. So let's get rid of all the key stuff. The other thing, we've got this left and right. We don't really need to have separate variables for those, so we could grab this whole thing and just move it in here. And we could grab this whole thing and move it in here. All right, starting to clean up really nicely. All right, I like how this looks, nice and clean. Let's see how we do. And that does it. Now we're beating 97% for runtime, and oh man, why does it keep doing that? All right, we're beating 97% for runtime and 18% for memory, so that is a huge win. Okay, there's still things we could do to clean this up, but I'm actually super happy with the 97%, and I'm pretty happy with just the look of this code. It's nice and clean, it's easy to read. That's really important. I don't emphasize that enough in these videos, but having nice, clean, easy to read code, well-formatted code, is a huge difference in a production environment when you're working with a lot of other engineers. Okay, so that is it for me. Hope you enjoyed this, hope you had fun, hope you learned something, hope you can go out and write better code.